Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 9 from chapter number 1, Measurements. In all the previous lectures, we have discussed about physics and measurements, system international, scientific notation, errors and uncertainties, significant figures, precision and accuracy, and dimensional analysis. Our chapter has completed now and we are moving towards the exercise in which we will discuss about multiple choice questions, conceptual questions, and numerical problems. Okay, so moving towards multiple choice questions. Our first MCQ or multiple choice question is that what is the radian measure between the arms of watch at 5 p.m. and we are provided with 4 options. Option A is 1 radian, option B is 2 radian, 3 radian and 4 radian. We have to choose the correct option from these given options. So how we are going to check out that what is radian measure between the arms of watch at 5 p.m. So first, for the solution, we will draw the watch which is at 5 p.m. You can see over here that over here the minute arm will be at 12 and our arm will beat 5, okay, as shown in figure. You can see over here. So what will be there? We will solve it in a circle. We know that we have 360 degrees. So we have 12 hours on the watch. So each hour space is 30 degrees, because if we are going to divide 360 degrees with 12, we will get 30 degrees for each hour, okay. So over here, for gap of 5 hours at 5 p.m. we are having a gap of 5 hours. Angle is 5 into 30 degrees. That will give you 150 degrees, okay. So for gap of 5 hours, angle is 150 degrees. Now what we have to do, we just have to convert this degrees into radians. So as we know that 360 degrees is equal to 2 pi radians. So if we are going to convert it into 1 degree will be 2 pi divided by 360 radians, and multiplying both sides with 150 degrees, you will get 150 degrees is equal to 2 pi into 150 divided by 360 radians. So we will get answer as 3 radians. So what we have done over here, we have checked out at 5 p.m. what is the place of arms of the watch, then we have calculated angle in degrees and then we converted it into radians. So correct option will be option C, 3 radian, okay. So we have calculated angle in radian at 5 p.m. okay. So MCQ number 2, 1 degree is equal to dash. So we have to calculate degree in radian, because in the given options, option A we are having a value 0.01745 radian, option B 1 radian, option C 3.14 radian and option D is 2 pi radian. So we have to calculate 1 degree in radian. That is again very simple. In solution, what we will do, we know that 360 degrees is equal to 2 pi radian and 1 degree is equal to 2 pi radian divided by 360, dividing both sides with 360. 1 degree is equal to 0.01745 radian. So what is the correct option over here? Option A, 0.01745 radian is the correct option. MCQ number 3, the metric prefix for 0.000001 is hecto, micro, deca or nano. So from prefixes table we have calculated, we have learned that thing, that if we are converting this into scientific notation, then what would be there? We will write it as 10 raised to power minus 6, okay, because we are moving decimal to 6 places. So that will be 10 raised to power 6, and we know that 10 raised to power 6 in prefixes to power of 10 is equal to micro. So what will be the correct option? Option B, micro. Metric prefix for 0.000001 is micro because it is equal to 10 raised to power minus 6. Number 4, which of the following is the correct way of writing units? A. 71 newtons, B. 12 millimicrosecond, C. 8 kilograms, and D. 43 kilogram per meter cube. So we will check out that which one is correct way of writing unit by using conventions for writing SI unit. For this we will check out option A, which is 71 newtons, but over here Newton is having capital N, and this is against the rule. We cannot write complete name of a unit with capital word. B is 12 millimicrosecond, two prefixes are combined, which is again not allowed. C. 8 kilogram, K is capital, which is again not allowed. D. 43 kilogram per meter cube. So this one is correct option. We are writing two units combined with one space. So option D is the correct option, 43 kilogram per meter cube. Number 5, a student measures a distance several times. The reading lie between 49.8 centimeter and 50.2 centimeter. This measurement is best recorded as A. 49.8 plus minus 0.2 centimeter, 49.8 plus minus 0.4 centimeter, 50.0 plus minus 0.2 centimeter, and 50.0 plus minus 0.4 centimeter. So how we are going to record this measurement? Okay, first we will calculate the average value and then we will calculate its uncertainty. Okay, so for average value we will add these two values, provided values, and divide it with 2. We will get 50.0. So over here you can see that option B and option A, they could not be correct. So only option C or D could be correct. So because we are having measurement as 50.0. Then secondly we will calculate the uncertainty. We will subtract the value, maximum value and minimum value. We will write it as 50.2 minus 49.8, that is 0.4, but half uncertainty lies above the average value and half lies below. So we will divide it with 2, that will give us 0.2, or we can write it as plus minus 0.2. So the correct option will be 50.0 plus minus 0.2. So option C is correct. Number 6, the percentage uncertainty in a measurement of 3.76 plus minus 0.25 meters is option A 4%, option B 6.6%, option C 25%, and option D 376%. We will simply calculate percentage uncertainty by using its formula. We know that percentage uncertainty is equal to least count divided by measured value multiplied by 100%. So over here least count is 0.25, measured value is 3.76, multiplied by 100% will give us 6.6%. So option B is correct option, 6.6%. Number 7, the temperatures of two bodies measured by a thermometer are T1 is equal to 20 plus minus 0.5 degrees Celsius, T2 is 50 plus minus 0.5 degrees Celsius. The temperature difference and the error therein is, we are having two temperatures, we have to calculate their difference. Correct option from these four options, option A is 30 plus minus 0.0, B 30 plus minus 0.5, C 30 plus minus 1, and D 30 plus minus 1.5 degree Celsius. Okay, so over here we have to find out the temperature difference, and we know this thing that uncertainties are always added. So without even calculating we can find out the answer. We will simply add the uncertainties, 0.5 plus 0.5, that will give us 1. Okay, so C option should be correct. Let's check it out. T2 minus T1 is equal to 50 plus minus 0.5 minus 20 plus minus 0.5 degrees Celsius. we will subtract the values and we will add their uncertainties, because uncertainties are always added. Okay, so that will give us 30 plus minus 1 degree Celsius. See, option C is correct. 30 plus minus 1 degree Celsius. Number 8, 5 meters plus minus 4% multiplied by 3 second plus minus 3.3% is equal to option A, 15 meter per second plus minus 13.2%, 15 meter per second plus minus 7.3%, 15 meter per second plus minus 0.7%, and 15 meters per second meter plus minus 15.3%. For solution, we will again apply the same rule that uncertainties are always added. So there is no need to calculate all these things. You will simply check out this uncertainty is 4%, this uncertainty is 3.3%, and when we will add these two, we will get 7.3%. So simply the correct option is option B, 15 meter second into 7.3%. Number 9, 20 meters plus minus 2% whole cube is equal to dash. 8 meter cube plus minus 1%, 8 meter cube plus minus 2%, 8 meter cube plus minus 5%, or 8 meter cube plus minus 6%. Which one is the correct option? Again, we don't have to calculate all these things. We simply know one rule, that power is multiplied with uncertainty. So we will simply multiply this power with uncertainty. 3 multiplied by 2 will give us 6%. So option D is correct. 8 meter cube plus minus 6%. Number 10, the number of significant figures in measurement of 0.0070860 centimeter are 3, 4, 6 or 9. So we will simply apply significant figure rules that leading zeros are non-significant, in between zeros are significant, and trailing zeros after decimal are significant. So over here we are having all these digits as significant figure. You can count it 1, 2, 3, 4, 5, 6. So we are having 6 significant figures over here, because leading zeros are non-significant. Number 11, how many significant figures does 1.362 plus 25.2 have? 2, 3, 5 or 8. So there is no need to add these things. We can simply apply the rules of significant figure again, that in addition, round the result by keeping only as many decimal places as are in the figure containing least decimal places of given value. So over here 25.2 is having least decimal places, hence correct option will be 3, because 25.2 is having least decimal place, and we will round off the answer up to 1 decimal place, which will give us simply 26.5. So 3 significant figures are there. Number 12, compute the result to correct number of significant digits. 1.513 meters plus 27.3 meters. Correct option may be 29 meters, 28.8 meters, 28.81 meters or 28.813 meters. Again, there is no need to calculate. We will simply apply the rule of addition, that round the result by keeping only as many decimal places as are in the figure containing least decimal places of given value. So we will only keep 1 digit after the decimal. That will give us option B as the correct option, 28.8 meters. Number 13, in 7.635 and 4.81 are 2 significant numbers. Their multiplication in significant digits is option A, 36.72435, 36.724, 36.72 or 36.7. Again, no need to multiply these numbers. We will simply apply the rule of multiplication, that round the result by keeping only as many significant figures as the quantity containing least number of significant figures. Over here 4.81 contains least number of significant figures, which is 3. So we will only keep 3 significant figures in the answer. So option D is correct, 36.7, which is having 3 significant figures. Number 14, the precision of the measurement 385,000 kilometers is 10 kilometers, 100 kilometers, 1000 kilometers, or 1 with 6 zeros, okay, 1 million kilometers. Okay, so if we are going to calculate, keep this in mind that in your book they are not considering trailing zeros as significant, okay. Trailing zeros are considered as non-significant in your book. So we will solve it according to that. Over here, considering trailing zeros as non-significant, 3 significant figures are there, so 4 doubtful digits are there, okay. So we can say that these 3 zeros are considered as non-significant, totally non-significant. So 385 is significant, 3, 8 and 5 are significant, and these are completely known values, and we will only consider 1 doubtful digit over here. 3 accurately known plus 1 doubtful digit. So our precision, our least count must contain 4 digits, okay, must contain 4 digit, because over here we are having 4 doubtful digits, okay. We are having 4 doubtful digit from which we are considering just 1. If you are having the value 385,000 kilometers, over here only 3 significant figures are considered, 3, 8 and 5. So it means that 3 and 8 are accurately known and 5 is doubtful. 3 and 8 are accurately known and 5 is doubtful. So in this whole figure, we are in this whole value we are having 4 doubtful digit. So our least count, our precision must contain 4 digits. If we are going to consider 4 doubtful digit, precision must contain 4 digits. So option C will be correct, 1000 kilometer, okay. 385,000 kilometer, 3 significant figures are there, 2 accurately known, 1 doubtful, so 4 doubtful digit in total. So our precision must contain 4 digits. Number 15, dimension m raised to power 0, l raised to power 0, t raised to power 0 are dimensions of option A strain, option B refractive index, option C magnification, or option D all of these. So no dimension, dimensionless, m naught, l naught, t naught means that no dimension. So we know that all these are ratio between similar quantities, and if we are having ratio between similar quantities, then it is dimensionless value, okay. So all of these are having no dimension, m naught, l naught, t naught. So strain, refractive index and magnification all are the ratio between similar quantities, so these are dimensionless. Number 16, the dimensions of torque are A mLt, B m square l square t, C ml square t raised to power minus 2, or D ml square t square. So we will solve it simply by using the formula of torque is equal to force into distance. We will apply dimensions on both sides. Dimension of torque will be dimension of F into D, that is mLt raised to power minus 2 into L. We are simply putting the dimension of force and distance. L bases are same, so power will be added, ml square t raised to power minus 2. So option C is correct option, ml square t raised to power minus 2. Okay, that was all for MCQs, and now moving towards the conceptual questions. Girls, you have to write down conceptual questions on your own. I will just give you the idea that how to write them. Some of the questions I am telling you that how to write those things, but you have to elaborate your answers yourself as well. Question number 1, for an answer to be complete, the units need to be specified. Why? Question is, for an answer to be complete, the units need to be specified. So without unit, our calculation, our measurement, our physical quantity specification will be incomplete. What is the reason? You have to give the reason first. You will write down the reason or statement, whatever the answer is. If the answer is in yes or no, you have to write down the statement. If you have to provide some reason, you have to give the heading of reason. Answer should be to the point, but with it should be covering each and every point. So reason may be without unit or description about any physical quantity will be incomplete. Our description will be incomplete. For example, you can give any example related to this. If you are telling someone about length of an object that it is 5, then our description is incomplete, because we don't know whether it is 5 meters, 5 millimeters, 5 centimeter, whatever. This description is incomplete. If we say that object has the length of 5 centimeters, then with unit centimeter, our description is complete. You can give many other examples as well, because if we are as you can say that if we are traveling from one city to another and we are telling that the distance is 10. What is 10? We don't know whether it is 10 miles, whether it is 10 kilometers, whatever is there. So without unit we cannot describe anything, any physical quantity completely. Okay, so you can write in your own words as well. This will be the format of writing. Question number 2, what are the advantages of using international system of unit? Why we are using SI? You have to write down the advantages. Advantages of using SI, you have to give proper heading and then you have to solve. You have to write it in points. Number 1, SI is used throughout the world. Okay, System International is used throughout the world. It has only one unit for each quantity. Why it is in advantages? It has only one unit for each quantity. It means that it is never necessary to convert from one unit to another within the system. Okay, we are having prefixes. We have to write down the prefixes of the values, but we are having just one unit for each quantity. For example, for length we are having meter. For length we are only having meter, no other unit. Centimeter, millimeter, kilometer are prefixes with meter, but we don't have to convert from one unit to another, so you don't have to learn different values for interconversion. Okay. Number 3, SI uses decimals exclusively, eliminating mixed number and fractions. So we are just using in points, 2 point this, 3 point something. We are just using decimal. We are not using mixed numbers and fractions in System International. That is another advantage of this System International. Number 4, the prefixes used in SI are short and convenient to use. Okay, you can easily use them. There are no mixed number, there are no fractions, simple prefixes are there. SI units are derived as product or quotient of few independent base units. So if you memorize those few base units, you can derive any unit, any quantity. Okay, you can write some other advantages as well if you want to. Question number 3, how many radians account for circumference of a circle? How many steradians account for the circumference of a sphere? We have done this in detail in radian and steradian topic. So you have to write down the statement first that there are 2 pi radians in a circle, and then you will derive whole relation for that. You will draw the figure and you will derive whole relation of radian. And in second part, how many steradians account for the circumference of a sphere? You will write down the statement that there are 4 pi steradians for the circumference of the sphere, and then you will derive the whole relation with figure for steradian. Okay, you have to do it. Question number 4, what is the least count error? How can least count error be reduced? We have also done this, and it is written completely in your books as well on page number 11, that what is least count error and how we are going to reduce it. You have to give proper headings. First, definition of least count, then least count error, and then how to reduce the error. Question number 5, why including more digits in answer does not make it more accurate? So first you will give the definition of accuracy, that it describes the closeness of a measured value to the actual value. Then you will explain it that if the value is not close to the actual value, then including more digits in answer will not make it more accurate. Okay, If it is not close to actual value, then it doesn't matter that how many digits we are adding, it will not make it more accurate. Okay, but keep this in mind that it will make it more precise. If we are adding more digits in the answer, it will make it more precise, but it will not make it more accurate if it is not close to actual value. Okay, so precision has nothing to do with actual value. So if we are adding more digits, that will increase the precision but not the accuracy. For example, let two students calculated value of g as 9.7 meter per second square and 9.326 meter per second square. Although first measurement consists of less number of digits, but it is close to actual value, so it is more accurate. And the second measurement 9.326, it is having more digits, but it is less accurate. So including more digit does not make it more accurate. Okay. Question number 6, what determines the precision of a measurement? Again, you can write down points on your own because we have done the topic of precision in detail. First, you will write down the definition that in many measurement, precision describes the degree of exactness with which a measurement is made and stated. Made related to instrument, stated related to measurement. Dependence, it depends upon amount of variation that exists in the value of multiple measurements of the same factor. So if values are close to each other, then they are precise. If not close to each other, then they are imprecise. The value is more precise if variation is less. Least count of instrument also determines its precision. For example, mass of a ball is exact mass of the ball is 2.5 grams and different measurements are taken. First one is 2.4 grams and rest are 1.9 gram, 1.9 gram and 1.9 gram. You have to write down the description over here that this, although the measurement 2.4 gram is more accurate because it is close to the actual value, but it is not precise. Precise value is 1.9 gram because these values are closer to each other. So this group of value 1.9 gram is more precise. 1.9 gram is more precise reading, 2.4 gram is more accurate. So it basically what happens, if degree of exactness is there, then the value is precise. It doesn't matter whether it is close to the actual value or not. Question number 7, if two quantities have different dimensions, is it possible to multiply and or divide? Can we add and or subtract them? So first you will write down the statement that whether you can do it or not. If two quantities have different dimensions, then we can multiply and or divide them, but we cannot add and or subtract them. Okay, then you will give an example that let A, you can take any random dimensions, A is equal to mLt raised to power minus 2 and B is equal to L. Then what you will do, we are taking two dimensions. First you will multiply these two with the heading of multiplication. You have to do it yourself. With the heading of multiplication, you will multiply A and B and you will write down the answer that yes, multiplication can be done. Then you will do division. You will divide A and B. This is again possible. Then addition, A plus B is not possible because these two are different dimensions. Subtraction, A minus B, again not possible because these two are different dimensions. These two values have different dimensions. So addition and subtraction is not possible. Multiplication and division is possible. You have to write down the statement. Okay. Question number 8, the human pulse and the swing of a pendulum are possible time units. Why are they not often used? We can set these two things as time standard, but we are not doing so. What is the reason behind this? Because these are as standard time of unit, these are having certain drawbacks, so we cannot use them as time standards. What is the reason? Reasons for human pulse. You can write down different reasons of your choice as well. Variation in heartbeat can cause sudden changes in human pulse rate. That is the drawback. It is not a fixed value. It is not. It cannot be set as a standard because there are variations. The pulse rate of a running person and a stationary person are different. There is a difference between the pulse rate, so it cannot be set as a standard. The pulse rate also changes due to increase in age. So again, what is there? Variation. Pulse rate vary from person to person, so it cannot be set as a time standard. It may change due to some disease as well, so we cannot set human pulse as a time standard. Okay, and reasons for swing of a pendulum. Swing of a pendulum cannot be set as time standard. What is the reason? We know that the time period of simple pendulum is t is equal to 2 pi under root L over g. Equation 1 shows that time period depends upon length and acceleration due to gravity. It is dependent, time period is dependent on L and g. So what is the drawback? As value of g at different places is different, so time period will be affected. You know that with height, with altitude, value of g is different, so it cannot be set as time standard. Number 2, length of pendulum may change, due to which time period will change. For example, if metallic wire is used, okay, and if it is summer season, that will expand. If it is winter season, that will contract. So even for a single pendulum, length may change, so time period will be changed. Air resistant affects swinging of pendulum, so air resistance is also another factor which is affecting time period of a simple pendulum. So we will say that simple pendulum and human pulse cannot be set as a time standard. Okay, if an equation is dimensionally correct, is that equation a right equation? If equation is dimensionally correct, then equation may or may not be right equation. You have to solve it with the help of an example. Okay, so equation is dimensionally correct. We know that according to principle of homogeneity, if both sides of the equation has equal dimensions, then it is dimensionally correct, but it may or may not be physically correct. This is not necessary that equation which is dimensionally correct is also physically correct, because what is the reason? Because dimensional analysis is having certain limitations. It is giving us no information about dimensionless constant. Okay, for example, you can take different examples. The equation S is equal to Vt plus 1 by 3. It is dimensionally correct but physically incorrect. Okay, because dimensions would be same, but its answer, it is incorrect. Answer is incorrect. It is physically incorrect. You can also give some examples related to correct equations. You can also write that this equation is dimensionally as well as physically correct, but you can write some other equation which is dimensionally correct but physically incorrect. Okay, so principle of homogeneity is telling us that if both sides are having equal dimensions, then it is dimensionally correct, but it may or may not be physically correct. So you can first write the statement, then reason and explanation, and then example. Okay, all the comprehensive questions which are in your book, we have already done. We have already covered those comprehensive questions. Okay, so you can check all these questions that we have already done, but you have to give extended response to the following questions. Okay, you have to write it in detail, each and everything. Okay, keep this in mind that same question can come into the conceptual question or in long question. So it's up to you that how you are going to elaborate your answer and how you are going to make it short. Okay, how you are giving a precise, a to the point answer of that. Okay, so in long question, in comprehensive question, you have to write each and everything related to the topic. Numerical questions. Number 1, a circular pizza in 3 equal parts. One piece of pizza is taken out. Estimate the degree of measure of the single piece of pizza and convert the measure into the radians. What is the radian measure of the remaining part of pizza? A circular pizza. Okay, we are cutting it into 3 equal parts. Circular pizza means we are having a complete circle. One piece is taken out. We are taking out one piece, and we have to estimate the degree measure of the single piece. Okay, we are having a complete circle which is divided into 3 equal parts. We are taking out one piece. We have to calculate degrees in that piece, then we have to convert it into radians, and then we have to calculate a radian measure of the remaining part of that circle. How we are going to solve it? Again, we have to follow the same format. First we will write down the given data from the statement, then required, and then we will start our calculations. Okay, so given we are having a circular pizza or a complete circle which is divided into 3 equal parts. We know that a complete circle is having 360 degrees, so 360 divided by 3 will give you 120 degrees. Okay, so we are having a circular pizza cut into 3 equal parts. Arc AB, BC and CA makes an angle 360 divided by 3, which is 120 degrees with center. So we are cutting the circle into 3 equal parts, which is giving us 120 degrees. To find part A, degree measure of single piece, a radian measure of single piece, and degree measure of remaining 2 pieces, theta prime. Okay, so we have to calculate 3 things: degree measure of single piece, radian measure of single piece, and degree measure of remaining 2 pieces. Okay, so separating one piece over here, we know that it is having an angle of 120 degrees. A single part of pizza is shown in figure. For this part we have theta is equal to 120 degrees, and simple answer is there, theta is 120 degrees. And conversion into radians, we can simply convert this degree into radians. We know that 360 degrees is 2 pi radian, 1 degree is 2 pi divided by 360 radians, and 120 degrees will be, by multiplying both sides with 120 into 2 pi divided by 360, we will get our answer 2.09 radian. So this is the answer. Radian measure of a single piece, degree measure is 120 degrees, radian measure is 2.09 radians, and part C will be remaining 2 parts. Okay, remaining 2 parts of pizza are shown in figure. For this we have theta prime is 240 degrees. We can see that 120 plus 120, that gives us 240 degrees. Conversion into radians, 360 degrees is equal to 2 pi radians, 1 degree is equal to 2 pi by 360 radians, and 240 degrees is 240 into 2 pi divided by 360 radians. So our answer is 4.19 radian. You can see double of 2.09, 4.19 radians. That is the radian measure of remaining 2 parts. So this numerical is done. Number 2, the length of pendulum is 1.5 plus minus 0.01 meters, and acceleration due to gravity is taken into account as 9.8 plus minus 0.1 meter per second square. Calculate the time period of the pendulum with uncertainty in it. We have done an example of simple pendulum, but over there we haven't taken acceleration due to gravity with uncertainty. Over here we are taking it with uncertainty. So again same format, we will first write down the given data, then required, and then we will start our solution. Okay, so if in given data we are having length and value of g, so we will write it as length of pendulum. We will write given data. Acceleration due to gravity, we will write the value which is provided. Then required is time period with uncertainty, t plus minus delta t. T is the actual value, delta t is uncertainty in it. Calculation, we know that time period of simple pendulum is 2 pi under root L over g. L divided by g. Over here quotient is there, division is there, and in division, according to the rules of uncertainty, we know that first we will find out percentage uncertainties and then we will add them, because in multiplication and division we need percentage uncertainties. So over here first we will calculate, we will write down the equation as this format: t plus delta t is equal to 2 pi under root L over g plus minus delta t. Name it as equation number 2. First we will find out the percentage uncertainty in length and acceleration due to gravity. So for L we have percentage uncertainty in L. You will check out the given value and you will write down least count divided by measured value multiplied by 100%, because value of L was 1.5 plus minus 0.01. So we will divide uncertainty divided by actual value multiplied by 100. We will get 0.67%. Okay, and one more important thing, that in the formula you can see that power of L is 1 by 2. So we will multiply delta L by 1 by 2 as well. We have calculated percentage uncertainty, we have calculated it, and we will multiply it with power 1 by 2. So what we will do, delta L is equal to 1 by 2 multiplied by 0.67%, that is 0.335%, name it as equation 1. So for calculating uncertainty in L, first we have calculated its percentage uncertainty by using the formula uncertainty divided absolute uncertainty divided by measured value multiplied by 100%, and we are also having power. L by G is in under root means power is 1 by 2. So we will multiply this uncertainty with 1 by 2. So delta L is 0.335%, equation number 3. In the similar way, we will calculate uncertainty in G, actual value uncertainty, absolute uncertainty divided by actual value multiplied by 100%, that is 1.02%. Again G is in under root, it is having power of 1 by 2, so we will multiply it with 1 by 2. So delta G is 1 by 2 multiplied by 1.02%, that is 0.51%. Equation number 3 and equation number 4 is giving us percentage uncertainties. So for uncertainty in time period, we will add these two uncertainties in equation 3 and 4. Delta T is delta L plus delta G, that is 0.335% plus 0.51%, that is 0.845%, and we will round it off up to one significant figure. That is a convention that we have to round off the uncertainty up to one significant figure, but if it is 1, then we can round it off up to 2 significant figures. Okay, that is a convention, just a convention, that uncertainty is most of the times rounded off to one significant figure, but if it is 0.1, then it can be rounded off to 2 significant figures. So 0.8% is total uncertainty in time period. Now we will calculate actual value of time. T is equal to 2 pi under root L by G. We will simply put the values 2 into 3.14 value of pi multiplied by under root actual value of L divided by actual value of G, which is provided in the given data, 1.5 divided by 9.8. So when we will calculate these values, we will get 2.512 seconds. This is the time period, and again it is rounded off to one place after the decimal. What is the reason? Because our uncertainty was having one digit after the decimal. So 2.5 second, putting values from equation 5 and 6 in equation 2, we get T plus delta T is equal to 2.5 seconds plus minus 0.8%. Okay, so you can check this out, that our format is correct, that our answer is having one decimal place in actual value as well as in uncertainty. So rounding off is done in this way, that both should be having same number of decimal places. Okay, so T plus delta T is 2.5 second plus minus 0.8% is the required answer. So we can say this is done. Numerical number 3, determine the area of rectangular sheet with length L plus delta L is equal to this and width, again given, calculate the area. That is very simple, you have to do it yourself. You will write down the given data, length and width. You have to write down required value, area with uncertainty, and then you will start the calculation. How? As area is equal to length multiplied by width. It is multiplication. So what you will do? Length into width. You will find out their uncertainties. You will find out percentage uncertainties over here, and then what you will do? You will add these two values. Okay, first you will find out percentage uncertainty in L. You will find out percentage uncertainty in width, and for delta A you will add these two uncertainties, and you will find area simply by multiplying length and width. Okay, you can do it. That is the simple question. Area is length multiplied by width. Values will be simply multiplied, and their percentage uncertainties will be added for delta A. Number 4, again same question as we have done in examples. Calculate answer up to appropriate number of significant digits. Addition, subtraction and multiplication is there. You will just do the calculation according to the rules of significant figures. You will round off in addition, and in subtraction you will round off up to the least number of decimal places, and in division and multiplication, you will round off up to the least number of significant figures. You have to do it. Number 5, calculate the answer up to appropriate number of significant digits. Again, part A, the ratio of mass of proton to the mass of electron. Values are given, MP divided by ME. Values are provided in scientific notation. And part B, the ratio of charge on electron to the mass of electron. QE over ME is equal to this value. We will solve one part and then you have to do the other part. So, again using the same format, write down given data required and then start the solution. So, in part A, given data is mass of proton and mass of electron. We can write it as mass of proton, mass of electron. Mass of proton is 1.67 into 10 to the power minus 27 kilogram. Mass of electron 9.109 into 10 to the power minus 31 kilogram. Required data, we have to find out the ratio between the two. We will start the calculations. Given is that this ratio is given. So, what we will do? We will divide these two values, 1.67 with 9.1096. Okay, we will divide these two values and what will happen? Power of 10, bases are same. So, powers will be added. Minus 31 will become plus 31 when it will move to the numerator. So, what will be there? MP over ME is equal to, we have divided masses 0.1833 into 10 to the power minus 27 plus 31. So, we have simply divided the values and we have added their powers. Minus 31 became plus 31 because when it moves from denominator to numerator, sign is changed. Kilogram is cancelled with kilogram. So, we will be having answer 0.1833 into 10 to the power 4, or in standard notation we can write it as 1.833 into 10 to the power 3. Okay. So, now what will happen in the given data? 1.67 represent the least number of significant figures. So, answer is rounded up to 3 significant figure. In division we know that answer is rounded up to appropriate number of significant figures, which the least number of significant figures which are present in the given values. So, we can write it as ratio between mass of proton and electron is 1.83 into 10 to the power 3. So, answer is rounded up to appropriate number of significant figures. In the similar way, you have to solve part B. Okay, you have to do it. You have to write down the given data required and then you will start the solution. Okay, so next two numericals we have already done in the previous lecture. So, that was done for numericals. The ratio, the answer is there 1.83 into 10 to the power 3, and in the similar manner you have to solve its part B. Okay, so I would like to end my lecture with this quote, that the task is not to see what has never been seen before, but to think what has never been thought before about what you see every day. Okay, so physics is not just like you have to discover new thing, the things which no one can see. Okay, but what you have to do, to think what has never been thought before about what you see every day. So, you can see everyday phenomena and you can find out new things within that. Simple is that you have to strengthen your imagination, you have to think about the universe. The more you will think, the more you will learn. Okay, that was all for today's lecture. Thank you so much.